Welcome to a lesson on geometric sequences. What is a geometric sequence? It is a sequence of numbers where each term after the first one is found by multiplying the previous one by a fixed non-zero number called the common ratio. So here's an example of a geometric sequence. The numbers are called the terms of the sequence, and in this case, the sequence is growing as we read from left to right. And so we'll be multiplying by a number bigger than 1. And the number we're multiplying by in this case is 3. That is called the common ratio. And each term in the sequence is denoted by a subscript and then the number of the term. So we say a sub 1, a sub 2, a sub 3, etc. The first term, which is a sub 1, is 2. The common ratio again is 3. The next term in the sequence then would be found by 54 times 3, which is 162. The seventh term in the sequence, well, we could list 7 blank lines, right, if we're ever asked to find the seventh term in a sequence, and we can just list the first terms, and then we can continue to multiply by the common ratio to get every next term. So the seventh term in this sequence would be 1,458. So what we want to do is we want to focus on a way of finding the nth term without actually listing every single term. To do that, we'll look at the same sequence we were just considering, but we want to write every term in the sequence in terms of that first term and the common ratio. So I want to write every expression, every term in this sequence as 2, maybe times 3. So to get 18, I need the 2, I need the 3, but I need to times it by another 3. Do you see the pattern here? To do the 54, I'd start with 2 times 3 times 3 times 3. And I keep adding one more 3 to the term. So then what we want to do is we want to see what's the same in every term and what changes. Well, what's the same is they all start with a sub 1. They all start with a 2. And then we're multiplying by powers of 3. So the first term is a sub 1. The common ratio is r. Now the nth term, okay, so this is where we want to see what's the same and what's different in every expression up above. They all start with a sub 1. We multiply by r to the power of n minus 1. Notice it's n minus 1. For example, 54, which is the fourth term of the sequence, is 2 times 3 to the third. 162, which is the fifth term of the sequence, is 2 times 3 to the 5 minus 1. So now to find the seventh term, we now can use this nth term expression that we have, and we can substitute n for 7 and a sub 1 for 2, and then we can just simplify this numerically. Using our order of operations, we're going to do the exponent here, and that's 729 times 2, which gives us the same answer as 1,458, but using this expression that we had for the nth term. All right, so that's going to be an important expression. Now, what I want to do next is think about what happens when r, the common ratio, is greater than 1. You can see that these terms are actually increasing quite rapidly, actually. And what we want to do is find a formula for the nth term of this sequence. So we're going to start with the general formula that we just wrote out. A sub n equals a sub 1 times r to the n minus 1, where a sub 1 this time is 5, and the number I'm multiplying by each time is 2. So here's my expression for the nth term of the given sequence. Now let's say we wanted to find the seventh term of this sequence. We can substitute 7 in place of our n, and we can first of all subtract 7 minus 1 for our exponent to get 6. Now we'll do 2 to the 6th power, which is 64, times 5 is 320. The seventh term of this sequence is 320. All right, last thing I want to consider with you is what happens if r, the common ratio, is less than 1. That is to say, the numbers are decreasing as I read from left to right. So you can think of this as dividing by a certain number, but what I'd rather we think of it as is multiplying by a fraction. So when we look to find a formula for the nth term, the first term in the sequence is very clear, 640. But the common ratio may not be overly clear. When we are dividing by 2, that is the same thing as multiplying by a half. So my common ratio is a half. Now let's go ahead and find the ninth term of this sequence. So a sub 9 equals 640 times 1/2 to the 9 minus 1. That's 640 times 1/2 to the 8th power. And when you do a half to the 8th power on a calculator, very often it turns out to be a decimal. We like to keep the geometric sequence problems as fractions if possible. So I'm going to write this as 1 over 2 to the 8th power, 2 to the 8th power being 256. So I'm writing this as 1 over 256. Now when I multiply across, I'm going to do numerators across over denominators across. I get 640 over 256, which simplifies to 5 over 2. And again, it's preferred if we can keep our terms as fractions when we're talking about geometric sequences. The answer of 2.5 would also be accepted.